So, welcome to this lecture. In earlier lectures, I talk about harmonic oscillator, its classical approach and quantum mechanical approach. Now, I will talk about the problem of harmonic oscillator using matrix algebra. Harmonic oscillator using matrix algebra. So, I will divide this lecture into three parts. So, first part is calculation of eigenvalues of energy, calculation of eigenvalues of energy. That is, I am interested to calculate this equation that En is equal to n plus half h cross omega. So this is our first part. And in the second part, I am going to talk about physical meaning of and properties of few operators, that is A dagger, A and N, where this A is known as A dagger is known as raising or creation operator. Raising or creation operator, and this A is known as lowering or annihilation operator, and it is a number. This N is a number or occupation number. Operator, because we will define these three operators in the derivation of this relationship. So their physical meaning will be discussed in the second part of this lecture. And in the third part, I am going to talk about eigenstates of energy, or eigenstates in position space, or in other words, I can say that I am going to talk about the evaluation of wave function for different states. So this is with it how I divided this lecture into three parts. So in this lecture, I am going to talk about only this part, and then I will talk about these properties, and then in the third lecture of this, I will talk about this. Okay, so let us start. So now, consider a Hamiltonian of harmonic oscillator. The Hamiltonian of harmonic oscillator is defined as p square over 2m plus 1 by 2 m omega square x square, as we discussed this Hamiltonian in the earlier lectures. So corresponding to these operators p and x, let us define new operators, and which are dimensionless and Hermitian. So corresponding to this p and x operator, let us define new operator p and q which are dimensionless because it's better to deal with the number rather than some physical quantity. So which are dimensionless and Hermitian. So P must be equal to this P over mh cross omega, which implies this P is equal to this operator will become this P into mh cross omega, and this Q operator is x m omega over h cross, or it can leads to that x operator is equal to Q over m omega over h cross. Let me call it as equation number 2. So using these values in equation number 1, the Hamiltonian will become this Hamiltonian, it will become this is P mh cross omega under the root whole square over 2m plus 1 by 2 m omega square. This is Q upon m omega over h cross under the root and its whole square, because here it is x square is sitting, right? So let me simplify it. It is p square m h cross omega over 2m. This will cancel out with it. Plus 1 by 2 m omega square. It is q over m omega over h cross. So this m will cancel out with it, and this omega, this 1 omega will cancel out with this omega, and it will go to the numerator. So the Hamiltonian will become h cross omega over 2. It is p square plus q square, right? And let me call it as equation number 3. So now introduce two non-Hermitian dimensionless operators such that this A is known as 1 by root 2 q plus iota p, and A dagger, it must be equal to, I will talk about their properties A and the dagger later on in the next lecture. Such that A dagger A, it must be equal to 1 by root 2 q plus iota p and 1 by root 2 q plus iota p. Let me simplify it. It is 1 by 2. It is q square plus iota qp minus iota pq plus p square. Now it's equal to 1 by 2 q square plus p square plus iota by 2, because I multiplied it with these two numbers, so it is qp minus pq, right? So this is basically a commutator. So that means this A dagger A, it is equal to 1 by 2 q square p square plus iota by 2. It is qp commutator. And the value of this commutator is nothing but is equal to iota. If its value is iota, then A dagger A will be equal to 1 by 2 q square plus p square plus iota by 2 into iota. That means this A dagger A, it can be written as 1 by 2 q square plus p square minus 1 by 2, right? So this is one relationship which I am getting. As I've written that the value of this commutator will be equal to iota, so let us have a look at it, that how it will become. So let me try to prove it here. So here it is, let us consider, yeah, it is qp. Let me put its values, m omega over h cross x and 1 by h cross m omega. Under the root, it is p operator. I just substituted their values. Now it's a commutator, so let me solve this commutator. M omega over h cross x into 1 over h cross m omega under the root p operator, and then it is 1 by h cross m omega p operator into m omega over h cross under the root x. Now this m omega will cancel out with this m omega because both are under the root, and this h cross into h cross will become h cross because both are under the root, and similarly this will cancel out with it. Oh sorry, square root will be there. So it means it is 1 by h cross, it can be taken outside, and inside it is xp minus px, and it is 1 by h cross, it is xp commutator. So the value of this commutator is equal to iota h cross. So this h cross will cancel out, so that's why its value will be equal to iota. That's what I have proved. And let me write down some equation numbers. So here it's equation number 4, right? And let me call it as equation number 5 will be this one, and say this is equation number 6, and let me call it as equation number 7. So therefore, now how I can proceed, that from here 1 by 2 q square plus p square, it must be equal to a dagger into a plus 1 by 2, and let me call it as equation number 8. Therefore, using this value, equation 3 becomes, if I substitute this value in equation number 3, the Hamiltonian will become this Hamiltonian is equal to h cross omega by 2 a dagger a plus 1 by 2, and this is equal to h cross omega by 2, it is n operator divided by 2. Here n operator, I called it as a dagger into a, and let me call it as equation number 9, and let me call it as equation number 10. Here this is known as number operator or occupation number operator. Occupation number operator, right? Now let us see the relationship between that. What is the relationship between this Hamiltonian and n operator? So let us try to find out their commutator. Sorry, this is equation number 10 and this is equation number 11. Yeah. So now consider commutator of h and n. This is equal to h n minus nh. It is equal to h cross omega n plus 1 by 2, and here n operator minus n operator h cross omega n plus 1 by 2, right? So here I simplify, means I put the values of h here, and then this equation will be there. Now let us simplify it. H cross omega can be taken outside because it is there, and this is simply a number, so it can be taken outside, and it is n cap plus 1 by 2 n cap minus n cap into n cap minus 1 by 2 n cap. So this will cancel out with it, and this will cancel out with it. So it is h cross omega into 0, so its value will be equal to 0. So that means commutator of h and n will be equal to 0. That means this h commute with n. That means if it commute, that means both h and n must have joint eigenstates and denoted by, let us say, n ket n. So mathematically, how this can be represented? So mathematically, I can say that if they have joint eigenstates, so that means when n is operated with n ket n, it gives you this equation, and similarly this h operated with n, it gives you e n n, right? So let me call it as equation number, this is 12, this is equation number 13. So now consider the Hamiltonian, or consider equation number 11. So if I consider equation 11, that is h must be equal to h cross omega n plus 1 by 2. So if they have joint eigenstates, so that means let us operate both sides by ket n. So if I operate with ket n from the right hand side, so it is equal to h cross omega n plus 1 by 2 ket n. So it is h n h cross omega n this plus h cross omega 1 by 2, right? So since it is, this part is equal to this and this part is equal to e n n, as clear from this equation number 13. So if I use this equation here, so that means this equation will become, this is e n ket n must be equal to h cross omega n n plus h cross omega 1 by 2 this. So here h cross omega n plus 1 by 2 and ket n can be written here. So means our equation will become this: E n ket n must be equal to h cross omega n plus 1 by 2 ket n, and let me call it as equation number 14. So using this, we have the value of eigenvalue of energy can be written as n plus 1 by 2 h cross omega. So this is the required relation for eigenvalue of energy of harmonic oscillator. So with this lecture is finished, and in the next lecture I will talk about the importance or the meaning of these three operators, right?